And the way you get the turtle to work is the top line of your program imports the turtle library, lowercase t. Then when you're ready to create the turtle, which we called Leo, after Leonardo, the Ninja Turtle, you create it like this. Leo is equal to turtle dot capital T, turtle. And then once you've done that, you give that turtle commands. You say, okay, I want you to have a certain pin size. I want you to run at a certain speed. 1 is the slowest, 0, oddly enough, is the fastest. So like you have the numbers 1 through 10, but then 0 is even faster than 10, whatever. So we say, Leo, go forward 100 pixels, and then turn left 90 degrees. That's the first side of the square. And then Leo, go forward 100 pixels again, and turn left again. That's the second side of the square. And we repeat those two commands one more time, 2 more times, and that draws a square. Then we change the color of it to red. And we want this shape to be filled. We're going to draw a triangle. So again, we go 100 pixels, but we turn 120 degrees rather than 90. And the way you figure out how many degrees to turn in a polygon, the angle is 360 divided by the number of corners. So 360 divided by 3 to make a triangle. 360 divided by 4 to make a rectangle. If you're going to make an octahedron, which is 8 sides, it'd be 360 divided by 8, which I think is 45. So we began to fill. We set a color. We began to fill. We went forward, we turned left, 120. We went forward, we turned left. We went forward, we turned left. And then we ended the fill. And that finished the triangle. So these are 90-degree angles. And those are 120-degree angles. So that was one of the programs we did. And again, let's lower the speed down to minimum. The turtle also comes with a circle command. So we drew one circle, we turned 90 degrees so that we were facing a different direction. We drew another circle, we turned 90 degrees, and so on. And so that looks like this. Set your color to green with a yellow fill. Then begin to fill, draw a circle in the fill. That way it filled it with color. If we commented those begin and end fills out, then we wouldn't have any, colors inside them. And then once the circle's done, turn right 90 degrees and repeat the process. Here was our third one. I don't remember what it does. Let's watch this one. Alright, this set it to kind of a tan background. The pin size is a lot smaller, a lot narrower. And this one's going to draw a whole bunch of things, so I'm going to set it to go faster. That's pretty boring. Let's change it back to maximum speed, or at least some medium. Okay, it still needs to be faster. Scotty, I need more power. There we go. Much better. Alright, so that's kind of cool. The way we did that is with a loop. We used a while loop. We said, I want to draw 45 circles. And so each time we draw a circle, we then want to turn a certain angle. If we were only going to draw 4 circles, it would be 360 divided by 4, so the angle would be 90 degrees each time. But we're drawing a whole bunch of circles. So the angle is much smaller, whatever 360 divided by 45 is. 8 degrees each time. So we have a while loop. While x is less than or equal to the number of circles, draw a circle, and then turn right 8 degrees, and then increase our counter. And this is a classic algorithm. This is a classic algorithm for repeating something over and over. You give an initial starting value to a counter variable, and then you do while that counter is less than or equal to your number of iterations. Then do some task, whatever it is, add one to your counter, and it'll keep repeating the code in the while loop until the counter finally no longer matches this specification. Now I started off with 1 and I went to less than or equal to zeros. Most programmers actually do it like this. Start off at 0 and then just go to less than num circles. That works the same way. It's still going to count 45 different times, but it's just counting from 0 to 44 rather than 1 to 45. Totally the same idea.
What's the difference between the while and if command?
If only goes in here one time. If I change that to if, watch what it does. Whew, that's pretty impressive. It went in here because of the if statement. It did all that code, but it didn't repeat it. So the next thing we will be talking about real soon is flowcharting, where we do a graphical representation of the logic. But you see what I mean? While means that once it ends, once it gets to the stopping of the indentation, it comes back up here and checks, is this case still true? And if it does, then it repeats it again. Very good question. All right, let's find out what the last one was. This is where we created two different turtles. We had one called Leo, turtle number 1, or if we wanted to be like, silly, we could call that turtle 0. And turtle number 2 was Alex. I don't know where we got the name Alex. We got that from the How to Think Like a Computer Science disc. That's not one of the names of the ninjas. Alrighty. So what we did is we set the first turtle to green, the second turtle to red. And we issued commands to each one of them. Hey Leo, I want you to turn right, but hey Alex, I want you to turn left. Then I want you both to go forward. I want you both to draw a circle. Then I want you to turn right, and I want you to turn left, and so on. So each one is being controlled separately. And the reason that works is because Leo and Alex are actually what are known as objects. An object is an entire set of data and the functions that work upon that data. So for the turtle to even work, it has to keep track of its X position and its Y position on the screen. It has to keep track of its pin size, its color, how fast it's moving, and also what angle it's currently drawing at, and whether it's in the process of doing a fill or not. So that's like 6 or 7 bits of information for each turtle, and there are probably more. And so Leo has all that information. He's got a color of green. Alex has got all that information, different information. We could change his pin size, we could change his speed so that he draws more quickly than the other one. And so when they run, we can see that one of them prints more quickly than the other one because we set his speed faster. The red one is faster than the green one. And that's because each one is its own object. And we could create a program with 30 different turtles. Now they can't run at the same time. It's still a sequential program. So we can't do 2 loops at the same time, but we can do 1 loop and then we can do the other loop.
So like when people like make games in Python and stuff, because people do that, how do they get like certain actions to happen at the same time?
Good question. I have not looked up game programming in Python. I've got a book on it. I just haven't started looking at it yet. I don't know if there are libraries which take advantage of multi-threading. Multi-threading is when you do 2 things at the same time. You have 2 threads of execution. And languages like Java and C++ support multi-threading really easily, and I haven't looked to see how Python does it. Same idea behind your processor. Nowadays chips have multiple cores, so that they could be doing 2 different things at the same time. That way you don't have to make the chip run twice as fast because chip speed improvements are becoming more and more difficult to do. because speed improvements in chip design is typically done by how narrow you make the pieces of the chip, all the pieces. And once you get to a certain narrowness, it becomes hard to engineer them to be even closer because the electrons have a tendency to jump from one wire to the one sitting next to it. And also, yeah, anyways, so as speeds become more difficult to increase, another way you can make the chip more powerful is to let it do more things at the same time. So you add cores. That's why your 4-core Intel runs faster than your 2-core Intel that you bought, 6 years ago or whatever. All right, so those are the turtles. That assignment is extra credit. I strongly recommend that those of y'all who missed it, just go ahead and do it. You don't even have to watch the video this time. This is like the only time that I've done this. The code for the turtles is just right here. And in a PDF. And I think I only put 2 of those programs in. No, I actually put all 4 of them in. So they probably take about 30 minutes to type in, depending on how fast of a typist you are. Or if I made these cut and pastable, oh no, you can get this done in 4 minutes. Anyways, go ahead and look at them, understand how they work, copy and paste the code. Just a word of warning, if you copy out of a PDF, it doesn't include the indentation. The indentions get messed up. So I would actually recommend you copy and paste out of the Word document. Just save each one to its own file name and have fun with the turtles. The reason I'm encouraging you to do that is we're going to use them later to explore more advanced programming concepts. If you want to read about the turtles, that's in the How to Think Like a Computer Scientist section. I think it's the 3rd chapter. Textbook, Think Like a Computer Scientist. There's one called Hello, Little Turtles. So you can work your way through that, because working your way through it, you learn more about it than just copying and pasting code. Obviously, that would not be the optimal way of learning it. Alrighty, Chapter 4, Functions. We almost should take a break and start talking about flowcharts. There's a program we're going to be using called Lucidchart. Let me post a link to it. Now Lucidchart works better, unfortunately, not unfortunately, but if you're a Firefox fan, you're going to need to use Chrome for it. You can still use Firefox for everything else, but Lucidchart does not get along well with Firefox. The problem is that when you type text, it just winds up being little black blocks. You could give it a shot, but can't guarantee it will work. Oh, that's actually not the link I want you to go to. Excuse me. There's 2 links, one to create your account and then one to log in. And I got the one to log in. We're going to need them both. Here's how to register for Lucidchart. Let's grab this one as well. There are other flowcharting programs out in the world. If you don't want to use Lucidchart, that's okay. If you've already have used in the past the one that comes with Microsoft Office called Visio, that's totally cool. I can't help you as much with Visio because I'm not familiar with it. The reason that I recommend Lucidchart is that it's cross-platform since it's a web app. You can do it on your Mac, you can do it on your Windows PC, your Linux, whatever. Alright, go to our home page. our D2L homepage, course home, you'll see two bits of news. One called registering for Lucidchart, and then the yellow one's called logging in. You're going to want to follow the register first. And you'll notice it has my initials in the name of it. And the reason for that is that it doesn't merely create an account, it creates a student account and links you to me as a teacher. So, since I'm already logged in, it's going to that. Let me log out and follow that link once more. So it's going to a new user account. Give it your name, Joe Bobson. And then just for tracking purposes, go ahead and put CIT1113 so we know who you are. And then your email address, I recommend you use your Rose email address rather than your home email address. Because if you're darkglobe@gmail.com, yeah, I can probably just look at your name. But anyways, I don't really go and I look at your assignments, but you're just going to need to remember your email and your password. So if you want to use your school's email and passwords, that's fine. If you want to make up another password, it's not like somebody's going to come in and steal your flowcharts. You know, I can't see your password, so it's not like I'm going to look up your password and learn any information about you. I could reset it. I just can't see it. Okay, so Joe Bobson. His email address is joe@raider.rose.edu. His password, in case you want to play with Joe, is Joe. And then I'm going to click sign up. And then notice that you can also sign up with your Google ID or Yahoo, but just go ahead and do it like this. It yelled at me because the password was not 6 characters long. Okay. Fine. And then get started. Alrighty. Fundamentals of flowcharts. I will put this in our PDFs, in our PowerPoints. But for now, you can look up here. Programming tools. Flowcharts versus pseudocode. And then this one goes on to talk about a hierarchy chart, which we're not going to use. So two different tools are used to convert algorithms into computer programs. And what is an algorithm? An algorithm is a step-by-step, it's a map for how a problem is solved. Like if you're going to calculate pi, there's a formula for calculating pi. Have we done the pi formula yet? No. Okay. There's an algorithm for it. We will eventually implement the pi algorithm in Python. We could draw a flowchart that graphically depicts the logical steps, or we could use pseudocode, which is English-like phrases. So here's the problem that they're recommending we try to solve. How many stamps do you use when mailing a letter? One rule of thumb is that you have to use one stamp for every 5 sheets of paper or fraction thereof. So if your letter is 1 page long or it's 5 pages long, you use one stamp. If it's 6 pages long, all the way up to and including 10 pages long, you have to use 2 stamps. So our algorithm, this is kind of the pseudocode. It's not really, but we're getting there. Requests a number of sheets of paper and call it sheets. That's the input part. And then divide the sheets by 5. That's processing. Round that up to the next whole number and call that stamps. That's more processing. And then reply with the number of stamps. That's output. So the first thing we're going to do to understand this is to graphically depict the logical steps and the order in which they're done. So the flowchart symbols. All of our flowcharts are going to start with an oval and end with an oval. And the technical name for the oval is the terminal. So we're going to put one at the top that says start. We're going to put one at the end that says stop or end. And that's used to begin, used to represent. This is like the you are here. You know, it's the beginning place in your Google Maps. And the end is like your destination. And then we have input, output. Input and output are done in this quadrilateral shape. I hate that because this is also quadrilateral, and so is this. The tilted rectangle. The processing is done in the regular rectangle. So if you ask the user to enter the number of pages, that'll be input. When you print the number of stamps, that'll be output. You will put both of those steps in tilted rectangles. Processing, when we calculate the number of stamps, when we divide by 5 and we round up, all of your math, all of your arithmetic, all your data manipulation gets shown inside squares. And then decision statements, which are your if and your whiles, are done in these diamonds. Then there are some more. Connectors, off-page connectors, predefined process, entity. Okay, yeah. Here's our algorithm for solving this specific problem. These are their annotations. So I shouldn't have skipped that fast, huh? Annotations are used to provide additional, they're just like comments. These are the comments. So start. Read sheets. We're going to read sheets somehow. Well, that doesn't tell us very much, but that's an input step. We know it's an input step because it's in one of those things. And then set stamps equal to sheets divided by 5. If I was going to word this, I might leave the word set off. I would just say stamps equal sheets divided by 5 and let you assume that you know what we're doing. Round the stamps up to the next whole number. Notice that this is not programming. This is not A equals R-A-O-U-N-D, however you spell round, you know, with a function, whatever. And then display stamps. You know, this isn't a print statement with the parentheses or whatever. These are not necessarily actual programming syntax, because a flowchart should be programming agnostic. So that if you take this and then you implement it in Python, or you implement it in C++ or BASIC or whatever. So the more syntax you put in here that is Python specific, the more confusing it would be for a programmer of another language. That said, I may get very specific in my flowchart and go ahead and put Python syntax in here just to make it easier to program from. So pseudocode uses English-like phrases to outline the task. Here's our pseudocode. Determine the proper number of stamps for a letter. Well, that's the description. That's not the part of the pseudocode. I'd want to put that in a comment, huh? Read sheets. Set the number of stamps to sheets divided by 5. Round the number of stamps up to the next whole number. Display the number of steps. Those are pretty much the same things that were in the flowchart, aren't they? The divide and conquer problem, used in problem solving. Take a large problem and break it into smaller problems, solving the small ones first. Break a problem down into modules. Alrighty, we're kind of wandering off in a la-la land here. Sequence. The sequence is the order in which the instructions are run. If there's no while loops, the sequence is very easy. It's top to bottom. But if there's an if statement, you know that there's 2 ways you can go. You could do whatever's inside the if statement. And if there's an else, you could do what's in the else statement. So that's a decision. If the answer to the question is yes, then you do one group of instructions. If the answer is no, then you do another one. And then looping is repeating something over and over. So this is our sequence flow chart. Let's draw this, but let's make it look more like Python. We're going to do exactly what I said we shouldn't do, which is to make it look like the Python syntax. So I'm going to go back to my web page where I was logged in to Python. I'm going to create a blank diagram, and certainly feel free to do this with me. And the way it works, really, I mean, this might be a good idea to watch, but okay, there, is you drag shapes from here and then you fill them in. So all of our flowcharts will start with a start. And I'm going to go to considerable effort to try to get all this to fit on one page, which you don't need to do. You can make these things as big as you want. And by big, I mean it's okay if you make your flowchart fill up 10 pages. I just try to keep it to fill all of one screen. So what is the first thing our program needs to do? We could go back and look at that algorithm, but maybe you remember. What's the first thing it does?
Does it ask for like how many?
Yeah, we asked for how many pages. Exactly. So why don't we use a print statement for that? Print how many pages to mail. And if you don't like the way it's breaking it up, you can embed carriage returns, or you can resize the box. And what I mean by embed carriage returns is you can pick where you want the line break to be, and then you can hit Control Enter. And then we want to connect those up. So I'm going to grab the bottom point of the start and draw a line to the top point of the next thing. And you want your arrows to go in the way that the instructions are being processed. You don't have to go top down. You could draw an arrow going off to the right, or the left, But I generally try to make them go top down unless there's something being represented other than just straight sequence. You zoom in and out with the control key, control and the mouse key, the mouse wheel. So I'm going to zoom out a little. Now we're going to input. We need to actually get that variable. Input pages. Or do I want to make it look more like Python? This is good for a generic one, or I could say pages is equal to input like that. Either one is cool. This is the exact Python statement, but I'm going to make it look generic. I'm just going to say input pages. And you're going, well, why don't you just pick one rather than making me type it 3 times? Okay. I'm going to draw a line between those two. Now we know the number of pages. We could put some extra checking in there. Like, what if they typed in 0 pages? You could laugh and say, no, you're not mailing that. Or negative pages or something. Now, we know something about Python, which is that if you get input from the user, it's a string, and you have to turn it into a number. So that's an additional step, which we could show in the flowchart, or we could leave it out. We would want to show it if we were creating the flowchart specifically for Python programmers. We could leave it out if we wanted to give this flowchart to any person. I'm going to go ahead and put it. I'm going to make a math step, which is the rectangle, which says pages is equal to int pages. That will convert it to an int. And then if we gave this to a C programmer, you'd look at that and go, well, that's stupid. But whatever. That's just a quirk of Python. But it's okay. It's a good idea to get used to the concept of converting from strings to ints. Because the C language and the Java language and stuff like that gives you these nice input routines that give you a number without doing the conversion. But then guess what? When you start doing web programming, internet programming, you don't get data in the form of numbers. You get data in the form of strings. And then you have to convert it into a number yourself with your program. And so Python is a bit more realistic in that respect. Now my lines aren't lining up, which is annoying me, but I'm not going to fuss with that too much. I can probably change something to get it to line up. Yeah, there we go. If you're obsessive compulsive, then you can spend hours drawing flowcharts. Why is this one in a whoopsie? Why is this one in a rectangle and these aren't?
Because in the rectangle, isn't that where like it's doing the math or whatever?
Exactly. Rectangles are for arithmetic. They're for data processing. the quadrilaterals, the tilted rectangles, are used for input-output. Now there are some people who like to use a different symbol for input. They like to use this one, manual input. And for output, they like to use, let's see if I can find it. Yeah, I can't even find it. It looks like a screen. Well, if I can't find it, we're not going to use it.
What is it saying?
It's not predefined process.
There's internal storage.
Okay, well, we're certainly not going to use it. Paper tape. Kind of shows you how old flowcharting is. We're not in the 40s anymore. We don't need paper tape. Alright, I guess maybe it's Visio that has a shape for displaying something and it looks like a cathode ray tube. Anyways, just use the quadrilaterals. If you really want to, you could use that one. I certainly wouldn't count you wrong. I would respect you for doing that, but I don't do it. Alright, now we have done the input section. I'm going to put a comment, an annotation saying what this does. So I'm going to bring an annotation, which is the brace with the triple equal sign, and we're just going to call this get input from user. Because really that's all that does. It gets input and it converts it into a number that we can use. If we wanted to make a higher level flowchart, that could just be one block. And I think that's how they did it on the flowchart in the PowerPoint. Now we're going to do a new section. And if I go too fast, let me know, because I've been using this program for a long time and y'all haven't yet. So under the pages, we're going to calculate the number of stamps, and then we're going to round it up. Now I don't even remember the Python command for rounding up. But we will find out. I know how to do it with modulus. We could check to see if the modulus is 0, and if the modulus is not 0, we could add 1 to our answer. But I'm sure that there's a math library.
I googled it and it just says round with parentheses.
Okay. Yeah, we'll find that. Okay. So let's calculate the number of stamps. It's a calculation, so it's going to be in a math box. Stamps is equal to pages divided by 5. But then we have to round it up, so I'm going to make that a separate box. Round stamps up. If I knew the Python command, I might put the syntax, but I don't, so I'm just going to leave it like that. Now I'm going to show you a trick that I sometimes do when I get annoyed with lining things up. Sometimes I just draw a line from one box to another box way down here, and even that one's not lining up right. And then I click on some of these and I right click and I do bring to front. So now that box is in front of that line, and that box is now in front of that line. You can just save yourself some time rather than connecting all the arrows. But then you don't have arrows on each box. So I think I'm going to undo that and go back to the way I was doing it before. But when we're drawing shapes that have 20 different blocks, or whatever in a row, I'll be tempted to do that. Okay, so this first section was the input. These two sections, these two calculations, are the processing. So let's annotate that. Processing, calculate number of stamps. And what's left to do? We're almost done. We know the number of stamps, but what have we not done yet? Did I hear somebody spit out the answer? What? Exactly. We haven't displayed our output. And so since we're displaying output, it's not going to be in a rectangle. What shape is it going to be in? Yeah, quadrilateral. So print use or stamps required equals comma stamps. If I wanted to make it look more like Python, I would put parentheses around the data that was being printed. I'm kind of wavering between making this Python specific and just making it general. Yeah. And then after that's just a stop symbol. Put an oval down here. Put the word stop. And let's put an annotation on it. Just say output. Output results. Then if you want, you can get really cutesy by filling it in with colors or changing the fonts. There's a place up here where you can pick predefined styles. Like, woohoo! But yeah, that made it all loopy and stuff, so I'm going to undo that. And I'm going to zoom out for a moment, and then I'm going to wander around seeing how y'all are doing. I guess I made my start and my stop box different sizes, but who cares? I will never count off just because you made boxes different sizes. But notice that there's no dead ends. Never make a flowchart that has a dead end. Always figure out, and I mean, yeah, this is easy. It wouldn't have a dead end. But once you get into if statements and while loops and stuff like that, then you can wind up with dead ends if you're not careful. With your flowchart, go ahead and crank idle up and see if you can start coding this. Now the syntax isn't right, and we don't even know the syntax for rounding stamps up. But you know how to make a print statement, and you know how to do it in input pages. I'll show you the syntax for doing the input pages. It looks like this. Pages is equal to input, like that. And a print statement looks like this. You don't have to change your flowchart to match, but when you actually start coding it, you'll do that. So just get yourself a head start on what I'm going to be doing. Alright, I'm going to give y'all a few minutes just to kind of process this, rather than just show you the answer right away. While y'all are doing that, let's look up how to do the rounding. Python roundup. It's called math.ceil, as in ceiling. And then if you want to round down, you use math.floor. So I'm going to go back to my flowchart and I'm going to change this step that says round stamps up. I'm going to actually put the syntax in it. Why am I clicking on a PDF? And you don't need to change your flowchart to actually have the syntax, but when you get to that point, it might be nice to have it up here on the screen. I was about to complain that I would have made that round up and round down, but I bet in other macro programming languages like Excel, they probably do the same thing. Nope. They use round. Okay. All right, I'm going to start working on it too. Yeah, here, let me show you the syntax for it. This red stuff right here.
That means you have to import math too, right?
I believe the math library is already imported. I think it's so commonly used. A lot of languages have a default library that is already imported, and Java is this way, and I believe Python is as well. We'll find out very soon. If you're getting an error when you type that in, then absolutely. That assumption is not correct. Let's call it stamps.
So this will we need to define stamps as an integer? Or
No, Python is a loosely typed language, meaning you can just go stamps is equal to blah blah blah, and you don't have to give it a type beforehand. Defining the type is a Java, C++ kind of thing. Very good question. The point where it becomes an integer is at int statement.
it says math is not defined.
All right. I'm messing this one up. That's pages is equal to input. Pages is equal to int pages. You're right, math not defined.
Yeah.
Yeah.
So I remember I used pi for that one thing.
Yeah, okay. So at the top of your program, import math. Don't put it in a comment. There we go. So when you test it with multiple conditions. Try 5 because you know that's supposed to be 1 stamp, and then try 6 because you know that's supposed to be 2. Try 10, try 11. Those are called boundary conditions when it's shifting from one behavior to the next. It'd be nice if this program ran over and over. It looped, but it doesn't right now. We didn't code any logic for a loop, so we just have to go back and do run module again each time we want to run it. Yeah, 6 is number of 2. Okay, that's working. So if you were working on it by yourself, that's cool. See if you get it running. If you need help, you can look up here to see how I did it. You don't have to word it the exact same way. You don't have to make your prompts say the same thing I did. Import math is the kind of thing you don't put in a flowchart and you just leave it to the suffering programmer to figure out. CEIL. Who needs a copy of this to check if you got a late start on the conversion? I'm going to print one for you. Or not. Wake up. Yeah, I'm recording all of this wasted time here. Okay. Well, seeing as how I don't know how to turn this, there we go. Alright guys, I'm going to give y'all a problem that's very similar. You ought to be able to flowchart it in 10 minutes. Let me go ahead and outline it for you. Conversion of Fahrenheit to C. So, ask user for temperature F. Convert temperature F. Let's make it a float rather than an int. Same syntax. So, temperature F is equal to float temperature F. That's how you do that. Then we have to do the calculation. Temperature C is equal to temperature F minus 32 divided by 1.8. And then print results. Do a little flowchart for that. Just scroll your stuff to the side and put it on the same page, or you could start a new document if you wanted to. And when you're done, you're going to want to export your drawing to a PDF. The way you do that is you go back to your chart. There is File, Publish. Choose File, Publish. Give it a name, a better name than blank document. Okay, don't choose Publish. I chose the wrong one. File, Download As. Choose File, Download As, and choose PDF. Or if you wanted to save it as a graphic, you could. Then it'll save it down. That's actually what I'm going to ask you to upload into the Dropbox, is that PDF. And if you don't get that done, that's okay, but I want you to, that's how we're going to fill up the last 10 minutes of the class.